So welcome everyone. I see a lot of new faces, a lot of familiar faces, which is great as well. Welcome to our May meeting of the East Brunswick Astronomy Club. This is the agenda that we have here for today. We'll do a quick welcome, then I'll introduce our speaker, Denis Cheng. Talk about conditions overview, but the reality is it didn't look too promising. At a certain point, the sun did come out, so who knows? We'll take a look and see. Talk about upcoming events for the club, as well as our partner, UACNJ, which I'll go into a little bit. And then do some open discussion about some things that are happening at the club. And if it's still clear out, we'll do some observing. So this is our mission statement. We're a fairly new club, but the reality is all it says is everyone is welcome to come to our meetings. No prior experience in astronomy is required. You don't need to have had a telescope. Some of the folks that are actually come to our meetings have viewed through a telescope for the very first time here with us, which is fantastic. And we love to see the reactions when they see the rings of Saturn or Jupiter or some of its moons, which is awesome to see. It's not just for adults or kids. Everyone is welcome. And certainly if you have a telescope, feel free to bring it with you, especially if you're having trouble with it. You can bring it to our meetings, and we'll do our best to help you out as best we can. If not, we can certainly Google and take it from there. But with that said, so the presentation for today is an introduction to amateur astronomy by Denis Cheng. And I'll read his quick bio here. Denis Cheng is a frustrated spaceman. His childhood heroes were Flash Gordon, Rocky Jones, and Commando Cody, but he grew up in the era just before spaceflight became an accessible reality. So he was sublimated his lifelong yearning for exploration and adventure by becoming an avid world traveler and explorer, backpacker, scuba diver, and of course, amateur astronomer. So with that said, let's welcome Denis.
Thank you very much for your kind introduction, Isaac, but really to give a little more depth to my background, I'm rather than just being a frustrated spaceman, which I am, I am currently a retired educator, okay? So, so besides my avid interest in astronomy, and this is what's frustrating is that even though I ended up getting into education instead of into astronomy, I really should have done something more in the area of astronomy education, as it were. But I didn't. I ended up getting into English. And so I spent almost all my life in the field of English language education, but I've also forayed into history. That was my second real area of interest. And I just got through this last 2 semesters at Rutgers University taking graduate history courses at my age in history so that I could transition in my retirement from teaching English to teaching history. So what this is not, this is kind of a misnomer, this title here. It's an introduction to amateur astronomy, but when I pulled this out, I haven't done this presentation in a long time, like over 10 years. So when I pulled it out of my files and dusted it off, I realized, oh my gosh, there's a lot of things in here that are not only a bit outdated, but kind of like dealing with areas of interest that are not really, or they're kind of all over the place. So the field of amateur astronomy is, just like astronomy itself, is huge. And it involves a lot of different things, technical aspects, as well as purely aesthetic aspects of it. So what I'm trying to do here tonight, I'm not going to get into the technical side at all. So see, what I had originally designed this for was as a technical presentation and talk about astronomy 101, as it were, sort of basic astronomy. But that's not what we're going to be talking about tonight. what I would like to do is to talk more about basically what amateur astronomy is and its relationship to history. And so to talk a little about the history of amateur astronomy. See, what is amateur astronomy? Well, it's a hobby or avocation in which its participants, that is amateur astronomers, do not pursue academic research in the field of astronomy as a professional goal. In other words, not to secure, use it as a primary source of income. B, they do not have specialized technical training or an advanced academic degree in the subject of astronomy. And this is obviously what appeals to all of us who are in the field, because it's really literally for everybody. You know, if you just have an interest in astronomy, you don't have to get any kind of special training. Amateur astronomers observe celestial objects in the sky with the naked eye or relatively small instruments and binoculars that are in many cases homemade or commercially available on mass market for the sheer enjoyment of doing so. You know what? One of the blessings that we've all enjoyed living in the society that we do today, not only of the 20th century, but now we're in the 21st century, is we have commercially available, fantastic devices that we can use to observe the skies. And you know, where it used to be, as you will see, because I'm going to talk something about the history of amateur astronomy and astronomy. You see, there was like some really bad, primitive stuff that people had to use at one time. And so a lot of them were so frustrated, amateur astronomers of the time were so frustrated at what was available at the Sears or Kmart in those days that you know, they ended up making their own telescopes and making actually very good telescopes just because what was commercially available was so bad. Well, that's really changed now, you know, with companies like Celestron and Meade in particular, Orion, all of these companies that are making amateur equipment, not only for professional astronomers, but for amateurs. What's available is really incredible, incredibly good. And I'm not an astrophotographer because I think the equipment out there, like the James Webb Telescope, does such a good job at taking pictures of the universe. I'll let them and that do that, and I'll be happy to look at their photographs. I don't need to spend a lot of money and time and effort to try to make my own measly photographs of the stars. I'm happy to just sit at a telescope with my naked eye and look at these things in person. So, but anyway, the equipment just to do that even, and to do astrophotography, again, is of amazing quality these days. Okay, however, many amateur astronomers have a high degree of experience and expertise in working in the field of astronomy, and often, this is very important, very gratifying in being an amateur astronomer, is so many have assisted professional astronomers in their academic research, and therefore they have made significant contributions in their research by that is tracking and even discovering celestial objects such as variable stars, asteroids, comets, and novae. Okay, so here are some efforts made by amateur astronomers, especially those who like to make their own telescopes, and it's astounding some of the things that people have been able to do on their own, just out of sheer devotion to the hobby for winding. But you know, they are standing on the shoulders of giants because some prominent astronomers from history, this is how they got their start. They started out by making their own astronomical equipment. here, backyard observatories, okay? So some incredibly, what's the word, ambitious, building right into the top of the house, building an extra dome here. And then here, that's there we go. Talk about your real do-it-yourselfer. Okay, let's go on here. Okay, so again, qualification characteristics of an amateur astronomer. Okay, no specialized technical training, no advanced academic degree, any amount of observational experience from none to hundreds of hours and decades of years. A sense, this is important, a sense, what does an amateur astronomer have to have? A sense of awe of celestial objects, resulting from not only from a view of their natural beauty, but also as a proper understanding of their technical descriptions. To really appreciate this, it's like looking at art, and really to enjoy art, you have to know something about the art, You have to know why it's considered to be beautiful, why it's considered to be exceptional, what has gone into the making of the art to make. And it's the same with celestial objects. How many people really appreciate that one of the Messier objects that we're going to look at, the Crab Nebula, is actually the result of an exploding star that took place, even though human beings, some ancient human beings, were lucky enough to have actually seen the explosion in the sky actually happen. Can you imagine what a spectacular sight that must have been to have actually seen the star that was the Crab Nebula actually exploding in front of your eyes, seeing that. But then also realizing that didn't happen just now, as you saw. That happened millions of years ago. What you're seeing is just something that happened millions of years ago and is just now reaching the Earth. Okay, so that kind of thing, if you realize these things, you get a better appreciation of the things that you're looking at and why they're so exceptional and extraordinary. Okay, to be able to appreciate what you're looking at, especially in the kind of equipment that amateurs would have, as opposed to what professional astronomers and astrophysicists are using, you have to have low expectations. You got to, again, know your equipment, know the limitations of your equipment, and know what you're looking at, what you're seeing, as opposed to other visions of the same thing that you may see in photographs, in books, in movies, in especially science fiction movies, where they have computer graphics to really play up the visuals and make you think that see things in ways that probably are not really real. So, and then finally, patience. We'll really get into talking about why it's really necessary. This is a quality is very essential for amateur astronomers. Okay, now we'll talk about, so when amateur astronomers get into this hobby, what are they doing it for? Why? So all of you who are here tonight get the idea that you might have some interest in amateur astronomy. Can I ask how many of you are sort of here for the first time? You've never really done much seeing, as they say. Okay, good. So a lot of this then will give you an idea of before you get much more into it, how much you may have to consider some of these qualities, especially this idea of patience. I can't preach this enough to new people who want to come into the hobby, and and just think they want to go right over to the first. Oh, what I forgot to bring. I as getting ready to come to this presentation this evening. Of course, don't you always get this feeling like you're leaving going, I'm forgetting something, I'm forgetting something. And sure enough, I realized I forgot to bring my telescope. I have a little small 3-inch Orion reflecting telescope, and I was going to use that to illustrate a couple of things here, and now I don't have that. But anyway, it's like most people think you would just like to go right over to the telescope, look in there, and they see the spectacular vision, okay, of Mars or the moon or whatever, and they're so disappointed because they don't realize, oh no, that it doesn't really look like that, like what the Hubble Space Telescope sees. You're not going to see what the Hubble Space Telescope sees. Okay. All right. Anyway. So what kinds of things are you interested in looking at? If you want to look at the stars, okay, so there is the sun and the moon, and there are the planets, but what else? What else would you be interested to see? What has sparked your interest in astronomy? Okay, stars in particular, but what about the stars? I mean, you can look in the sky, you can see millions of stars in the sky, but is there anything in particular that's of interest of any of those stars up there? Are you aware that some of those stars are actually binaries? That means that there are 2 of them, 2 paired together, and they orbit around each other, that kind of thing. Are you aware that there are these things up there that when you look at one spot of light, that may not be just one star, that may be thousands, millions of stars composed together, and what we would call a cluster. And that, again, some of those spots of light are not dense balls of gas, glowing gas, which is what a star is, but nebulous clouds called nebulas, things like that. So anyway, so one of the most popular objects, or the bread and butter of amateur astronomy, okay, are these things called the Messier objects, okay? So what are the Messier objects? Okay, well, they were we can't say they were discovered by this man, Charles Messier, because they've been in the sky for thousands of years. And many people, many human beings before Charles Messier came along in the 18th century saw them before he did. But why do we call them Messier objects then? Why are they given his name? Well, because he was the first one to actually identify them, give them a name, even though he didn't identify them in saying exactly what they were, because he didn't even know himself when he saw these objects up there. He just saw something there. He said, okay, I'm calling that M1. And this other thing over here, I'm calling it M3, okay? And nobody else before had ever done that. They'd seen the same things there. They didn't know what they were either, but at least Messier made an attempt to catalog. This is the scientific method, is to take something, even if you don't know what it is, you examine it, you identify, give it a name, put it into a place in a catalog, in a classification system, so it can be properly studied at some other time, especially with more advanced technology when it finally comes along. Then we have it there to study, you see. So we have Charles Messier to thank for doing. Now, the reason why he did this is actually kind of amusing, because even he, as a scientist, as an astronomer of the 18th century, he wanted to apply the scientific method here and catalog and document these objects, but not because he was really interested in them. It was just the opposite reason. He wanted to label them, put them in a category so we could discard them, because at the time, what do you think human beings have always been, beside the sun and the moon and the stars and the planets, what have human beings been looking up at the sky out of interest? What were they really interested in seeing, from thousands of years ago? Constellation. No, because you would take the stars and you put them into patterns. See, that's again the human desire to classify and categorize things, which is helpful to do that, yes, to make constellations. But no, what were human beings looking for? They would see something and would excite them. What would this be?
Meteors.
Huh?
Comets, meteors.
Yes, good. Comets in particular, but meteors too, because these are things that seem to be moving in the sky, and they look like fireworks, okay? There's something spectacular to see. And comets not only appeared to be fireworks of some kind, but many people assumed them to be supernatural, paranormal kinds of entities, living beings of some kind, dragons, a human being that was transformed into another kind of a being, gods, things like that. So anyway, this interest in comets reached kind of a peak in the 18th century. There was a kind of a comet fever at that time, and it was, let me get my notes here, particularly, let's see, there was an intense, a period of intense comet activity occurred in the 18th century, and it was highlighted by the appearance of Halley's Comet. You all heard of Halley's Comet, which appeared in 1768. No, excuse me, it was I think it was 1758, and then 2 years later, the appearance of what was called the Great Comet of 1760. So anyway, so this was, you could also say, the real beginnings of amateur astronomy, because everybody, not just the professional astronomers like Charles Messier here, who was, by the way, an astronomer for the French Navy, and for obvious reasons, right? We'll talk about this in a second. But anyway, so just regular, the mass public was becoming more interested in watching the skies because they were all looking for comets. And so Messier said, okay, I shall use my observational abilities as a professional astronomer for the French Navy to categorize, to help look for comets, because we don't want these other fuzzy things that are appearing in the sky, besides what we know are stars, what we know are planets, but then there are these other fuzzy things up there which we don't want to confuse for comets. So I will identify them, catalog them, and then we can forget about them, okay? And keep looking for comets, which is what we're really interested in. So that's how he started his catalog, the Messier catalog. And now, keep this in mind, these were all objects that at that time the sky was dark enough that you could look up even from the middle of Paris, okay, the center of Paris, you could look up, you could see the Milky Way. Can you imagine? That's a marvel in itself, to think that we once had skies dark enough that we could stand in the middle of big urban centers like New York City, look up and see the Milky Way. Boy, those days are long gone, that's for sure. Anyway, so Messier from the center of Paris would look up and see these fuzzy little objects, and made a catalog of, by, what is it, 1770, he had 45 diffuse non-comet objects, and then continued to catalog, and by he had assistant by the name of Pierre Méchain, and by 1781 they had compiled 103 of these objects. Even then, it was his catalog wasn't really finished, because from 1920 to 1966, other astronomers and historians who would go through his notes and see that he made other little side notes on the side of his main notes here. He said, in which he mentioned some other object he saw, but he didn't think it was worth cataloging, so he just ignored them. So these more recent astronomers then would go and look up those objects and then add them to the catalog, okay? So that the eventual full number came to 110. Okay, so let's take a look at some of these objects. Okay, so here are the more accessible of these objects today with all of our light pollution and everything. These four up at the top there, they're visible with the naked eye. You have the M13 Hercules globular cluster. Anyway, so we have these objects, the Great Andromeda Galaxy. That's one of my favorite objects. That's, in fact, I believe it is the galaxy that is closest to our own galaxy. So again, you know, if we're looking for a place which might have life, intelligent life, this is certainly one of the places that it could exist. It's our nearest galactical neighbor. Then we have a nebula in Orion. You know, Orion the Hunter has a belt and a sword that dangles down with 3 stars. And the Great Orion Nebula is in the star at the very bottom of the sword tip. The Pleiades, or the Seven Sisters, and this figures very prominently in human history. So many ancient civilizations have myths and legends regarding the Pleiades or the Seven Sisters. All of the ancient astronaut theorists also like to say that this is the origin of a lot of these ancient astronauts who have come and visited the Earth, and who are still amongst us, by the way. Okay, then we have visible and very small telescopes, like the one I was going to have here, a 3 to 4 inch, it's about this big, telescope. You can see things like the Great Globular Cluster, the Whirlpool Galaxy, the Ring Nebula in Lyra. I don't know if you've all seen pictures of that or not, but that's very popular. And then this galaxy in Ursa Major, which is paired with another smaller galaxy called M82. Okay, let's see. Why is patience so necessary for amateur astronomers? Well, because it takes a lot of time to set up and adjust equipment. It's a very precise, complex, and often very lengthy process. So it usually took me, when I still had my 8-inch Schmitz Meade SCT telescope, it was a very simple piece of equipment, but it would still take me a good 20 minutes to half an hour, not just I had to take the telescope out of my car, set up the tripod, set the scope onto the tripod, but then I'd also have to arrange my table, okay? Get my table out, get my laptop out here, get out all my eyepieces, get that set up, open up my chair. Okay, it's like it's an involved process, and then to align the telescope, you have to align it to a north-south axis and make sure. Now, see, a lot of the technology has advanced to the point where many of these scopes now are just simply you set them up, put them on the tripod, and they're ready to go. You just aim at whatever object it is that you want to begin with, and it from that point on, it is able to then find other objects and keep that object in view without your having to do anything to it. So, okay, the observer must sit or stand perfectly still at the eyepiece for several seconds or even minutes and concentrate and stare at an object to see any detail, okay? So it's not just, oh, we come up there, look at it, and oh, you see everything. No, sometimes to be able to see particular details, even colors or something, you have to really stare at the object for more than a few seconds, maybe a few minutes. Okay, also, what you see is what you get. So here we see the planet Jupiter. These are Hubble images, okay, of Jupiter. You can see this. Wow, this is spectacular. When I can hardly wait to get my telescope, either my 4-inch telescope or my 8-inch. So what I have is an 8-inch scope, and boy, I'm going to get that. I'm going to look at and see all these beautiful images of Jupiter. Well, no, this is really more what you see. Okay, this was what I was looking at. But I'll tell you, I loved it. I could come up and look at this no matter how many times I spent all that time to set up my scope, and I'd look in there. And don't see any of this color there, but man, I could look at that for the next couple of hours, and be very happy. And then here you see the 4 moons, okay? So how much passion, you see, do you have for this subject that something like this would be enough to keep you coming back, time and again to do that? Or is this really what you're not going to be satisfied unless you see this, huh? Okay, here's Saturn. Again, beautiful Hubble images of Saturn. This is what you see, okay, in a typical telescope, 4 to 8 inches. Again, I always got so excited when I saw this, But other people, okay. Here's Mars, okay? Especially in science fiction movies, oh man, Mars looks so appealing. It looks so threatening. It looks so spooky, so monstrous. Back in 2003, there was the Mars opposition, okay? Were any of you around at the time? And did any of you look into a telescope at that time? Because at that opposition in 2003 was the closest that Mars had come to Earth in 60,000 years. It was really a special event. So at that time, I was living in California. I was living in San Diego, and I was a member of what was called the Mars Society. And that weekend of the opposition, we went to ourselves and all these other amateur astronomy clubs. We went to Balboa Park, and we set up equipment, so that the public could come and look through the equipment at Mars. And I had that little small 3-inch reflector, okay? And it wasn't even on a tripod, it was on a table. Now these other guys, they had these large Dobsonians all the way up to like 12 inches, with camera set up and all this other fancy stuff on there. And you know what? I had the longest line. I don't know why. People didn't care. They didn't want to go and look through these larger scopes. They wanted to look through this little small one. I think they were very curious as to what it would really look like through a small scope that they could probably get for themselves. So they really wanted to see what it looked like. Well, this is what they saw, okay? We saw something like this, but it was so, even though the image was so small, it was so clear. You could see the light areas and the dark areas very clearly, And so all these people, one by one, they come up and they look through. They seem to be satisfied. They seem to be happy. This one woman, young woman, comes up. She looks in there. She goes, "Is that it? That's it? That's it?" Like I want my money back. You know? So again, this is something. Again, how much passion? How much are you willing to see reality like this instead of something like this? Okay. So this is M42, and this is that nebula in Orion's belt that I was talking about. This is the Crab Nebula, but here again, this is the Hubble image. Whoops. So this is the Hubble image, but this is what you'll see in your telescope. And I never got tired of seeing this. I saw that, and I was always as amazed the 15th, 20th time I looked at this as the first time that I did. I never did see the Crab Nebula through my telescope. I was never able to find this, but that is what you would probably see. And that, I think, is amazing. That is something that I wish I had seen through my telescope. Okay, here is the Andromeda Galaxy. There it is, beautiful Hubble image of the Andromeda. This is what you usually see in a telescope. And again, I was just always as fascinated staring at this thing for a couple of hours every time that I found it and put it in my scope. I was at the camping with some friends I was teaching at a university in Abu Dhabi and we went camping a lot in the Liwa Desert. So talk about a perfect place with good or almost non-existent light pollution. We're out in the middle of the desert in the shadow of the Tal Mori, which is the largest sand dune in the world. And I had focused my telescope on this, and I called my friends over. These are other teachers at the university. And one woman, you know, she could see how excited I was, and she looked in there, didn't say a word, turned around, went back to her tent, got in her sleeping bag, and that was it. You know, it's like, you got me out of my sleeping bag for that? Okay, notable ancient amateur astronomers. Okay, so we have the Sumerians, Babylonians, and Assyrians, okay? So what they were most interested in were solar and lunar eclipses. And of course, Venus. Venus was such an object of interest to all of the ancient civilizations because in many cases it was a god, or she was a goddess. This is a Sumerian zodiac, so all ancient civilizations seem to share a zodiac, and then they all made star charts. So what's important to human beings, especially even ancient human beings? Why were they so interested in the stars and creating things like this, star charts in particular? Because this is the basis of a calendar. This is the way we keep track of time of the seasons. This is when we can determine when to plant, when to harvest, okay? Things like that. This is why astronomy was very important to ancient civilizations. The Egyptians, this is the Egyptian zodiac. In the pyramids, the tombs, they have these incredible, on the painted at the top of the tombs. See, I got my original BA in archaeology, anthropology and archaeology, and I've been to the pyramids and to the Valley of the Kings and gone inside some of these tombs, and it's amazing what you can see painted on the inside, and on the ceilings they paint the sky, the stars. The pyramids were designed with these special mysterious shafts that point out. They're actually open to the outside, and in many cases they find that they are actually directed at specific constellations. The Great Pyramid in particular has a, quote, ventilation shaft that goes all the way to Orion's belt. And they found that this configuration of Orion's belt is particularly significant to the Egyptians. Okay, here are the Chinese. Even on the coins of the Chinese, they have inscribed certain constellations. Okay, this is a museum in Beijing, which I went to when I was teaching at a university in Beijing, in China. And it has all of the astronomical equipment that was developed in ancient times in China, dating from about the 13th century. And here, of course, is the Crab Nebula, which Chinese astronomers were fortunate enough to actually see being created. In other words, they saw the star exploding. And they were big fans of comets as well, comet chasers as well. And then, of course, there are the Arabs, who during the medieval times, the Middle Ages of Europe, they actually had a very high civilization, very scientifically developed civilization, and they were very much involved with astronomy, so that to this day, many of the stars that we know bear Arab names. So we have here Aldebaran, Algol, Betelgeuse, Deneb, Rigel. Okay, these are all Arab names. Okay, and then of course there are the Greeks with their and they were the ones who first came up with the idea that there was a concentric motion of the planets in our solar system. Unfortunately, the one thing they didn't get right was they put Earth at the center, okay? But everything else, they realized that everything else sort of moved around in concentric circles around a common source. There's this famous, or should we say infamous, Antikythera mechanism, which seems to be something that is so utterly advanced for the time. And again, they've been trying to figure out what it's used for. And the only thing that they've come up with so far is that, again, it was probably an astronomical device of some kind. Okay, then the Mayans, of course. And there are one of the most prominent structures amongst their ruins that we discover in archaeological digs these days are these observatories, amazing observatories. And again, Venus figures from what writings we have of theirs. We find that Venus, again, was such a significant object in their religion. And then, of course, there's the famous Mayan calendar, who of all the ancient peoples, it is amongst the most accurate calendar. Okay, so how come it ends in 2012? No more Twinkies. Well, according to the Mayan calendar, there was something. The end of time was supposedly going to happen in 2012. Now, outsiders, that is Western people, modern Western scientists, or not even scientists, because they weren't stupid enough to stick their necks out to say this, but a lot of people like ancient astronaut theorists would say, oh, well, because the end of the Mayan calendar is happening in 2012, that means it's the end of the Earth or the end of the universe. And that's not what the Mayans meant at all. They meant that this was the end of a cycle of some kind, and it would be probably a rebirth, recreation of the universe in another form or something like that. It did not mean that it was an apocalypse or the end of the universe. Okay, and then the theories about Stonehenge, so that these are Neolithic Britons, okay? Again, people from at least 5,000 years ago built these huge circular types of structures. And again, the most predominant theory today is, again, they were used for astronomical calculations. In other words, again, to keep track of the movement of the celestial objects, to help them to, again, keep track of time, of the seasons, and that kind of thing. Okay, so amateur astronomers today provide assistance support to professional research programs like these. These may be, I'm sorry, because I originally wrote this a good 15 years ago. So a lot of this is probably out of date. Amateur Sky Survey, American Association of Variable Star Observers, Hands-on Astrophysics, Pulsar Research Collaboration. Anyway, if you really get involved in amateur astronomy and you'd like to make you think you've made some kind of a discovery, or you'd like to help out with some kind of professional research projects, this kind of thing, you can probably get in touch with one of these associations, and they could they have some connection with a university or a government agency, NASA maybe even, and could help out with some kind of project, professional astronomy project of that kind. Okay, some notable contemporary amateur astronomers and their contributions. Okay, those of you who have been in amateur astronomy for some time now, you must know something about John Dobson, right? He is the inventor of, speaking of the advanced amateur amateur astronomy technology that we enjoy today. We have John Dobson to thank for, because he's the creator of the Dobsonian telescope, or the ultra economical light bucket, as we say. So we could take a simple tube, could be even made of cardboard. You put a mirror at the bottom of it, a curved mirror, and you've got a telescope, okay? You don't have to spend thousands of dollars. So he perfected the technique for making these very simple reflecting telescopes, which are very effective and just a lot of fun to make up. And again, you could do this all on your own and not for a lot of money. And it's really advanced the hobby of amateur astronomy a great deal. Okay, then we have here a American science writer, David Levy. Does the name Levy ring a bell with anybody? Okay, discovered the comet Shoemaker-Levy 9 in 1993, okay, which eventually impacted into Jupiter the following year. This event was tracked by multitudes of professionals and other amateurs. Is now a professional. So a lot of amateurs, people who started out as amateurs, now have become professional astronomers. Okay, and then if you know about Shoemaker-Levy, then you must also have heard of Hale-Bopp, okay? So Hale-Bopp comet, Thomas Bopp didn't even own a telescope, but discovered comet Hale-Bopp independently of co-discoverer and professional astronomer Hale. So they both together in 1995 discovered the Hale-Bopp comet. Okay. Contemporary. Okay, then Robert, an Australian. See, we even let the Aussies in on this too, you know. Robert Evans holds the world record for number of supernovas that he's discovered, 42. Good for him. Australian computer programmer Anthony Wesley discovered huge meteoroid impact on Jupiter in 2009. Now you Hale-Bopp, what was the other one we said? Shoemaker Levy. Now, do you remember Seki and Hayakutake? So they both, two Japanese amateurs, discovered Ikea Seki comet in 1965, and then Hayakutake discovered his in 1996. Okay, now we get to the conclusion of my presentation and my favorite part, because we're going to talk about three historical amateurs who are very much worthy of note. And I call them, and they are in fact the foundation, they help create the foundation of modern astronomy and astrophysics. And I call them the King, the Prince, and the Grand Duke. So let's start with the Grand Duke. And this was William Herschel. Okay, this is his time frame, 1730, 1817. Began his career, his professional career, not as an astronomer. He was a musician and a composer. And he was born and grew up in Germany. He was a German. But he moved, I forget the reason, it escapes me, he moved to England in 1761 and became an amateur astronomer. He constructed, but in his pursuit of his hobby of amateur astronomy, so between sessions of his playing music, which is what he was making his money from, so in his free time, he would go to his telescope and observe objects in the sky at night. But he was, again, so frustrated by the poor quality of telescopes that were available at that time. So he just said, you know, damn it, I'm going to start making my own. So he, it was at that time that Newton, Newton almost 100 years earlier, had invented the reflecting telescope, which was so much simpler but so much better than the refracting telescope. You know, the spyglass that you usually see, that's a refracting telescope. Very simple, but it's actually not a very good optical instrument. The reflecting telescope that Isaac Newton eventually came up was much better, because the thing that magnifies the light and the object that you're looking at is a mirror, not a lens. See, light, when it goes through anything, even glass, will distort, and it will lose its brightness because it's going through something. However, if you have a mirror, you have your object that you're looking at, that you want to magnify, it hits this mirror that's curved, and that magnifies not only the size, but the light of the object that you're looking at. So you're not losing any light, in fact, you're magnifying the light. So that's why reflecting telescopes are definitely superior to refracting telescopes. So Herschel decided, okay, I'm going to start making my own reflecting telescopes. And he ended up making very good ones. They were so good that then he could start selling them to professional astronomers, and he made money from that. So he started to get out of the music business and into the astronomical equipment business. And then, as a result of his work with making telescopes, he would spend more and more time looking through them himself and started discovering so many what we call today deep space objects. So things like galaxies, nebula, things like that. And he constructed more than 400 telescopes. Okay, He eventually discovered Uranus, the planet Uranus, in 1781. He was appointed king's astronomer. Here's a German immigrant, comes to England, and he becomes the King George III's astronomer in 1782. His greatest project was to create, at the time, the biggest telescope in the world. Reflecting telescope, you can see it here. The mirror was 40 feet wide, okay? The problem was, not only does it really look, not only was it as clunky as it looks here, okay, it looks pretty clunky, very difficult to move around. It didn't have the technology in those days to move an object of that size around very well. And second of all, as good as he became at polishing mirrors and developing mirrors, he couldn't, something that size just had not been tried before. He didn't have, again, the technology to help him to create a really good mirror. And so the images that you could see through this telescope were not very good. They were always very dark and not very clear or distinct. So we have to say that, unfortunately, it turned out to be a failure. It was the first attempt to make a really big telescope, but unfortunately, it was a failure. He discovered infrared radiation and sunlight in the 1800s. He proposed the name asteroid. So he came up with the name asteroid for large objects discovered within the solar system. Here again is another picture. Again, today's picture taken from a telescope like the Hubble telescope. We can see Uranus so well today, both Uranus and Neptune. We now, with the advanced telescopes that we have, we see that they are actually like Saturn and that they have rings around them. Okay, you can't see them with the regular optical telescopes that we have. You need special electronic telescopes, which are able to pick up the spectrum that these rings appear in, okay? Okay, over a 20-year period, he observed 2,500 new nebulae, star clusters, and recorded them. So he was one of the first to come up with a catalog of deep sky objects, of objects that Messier couldn't see. He was using too small a telescope. So Herschel was the first one to see really deep sky objects, much further away, in which you absolutely could not see them without a telescope, and a very powerful telescope. So this was called the General Catalog of Nebulae, which eventually became the new General Catalog, and which we know today as the NGC catalog. And this was the backbone of modern astronomy for the longest time. One of the interesting things about Herschel, why I love this guy, he believed that every planet in the solar system, including the sun itself, was inhabited by life. So he really believed in aliens, okay? So God bless him. He was now, here's, again, something I had to catch just before I came this evening to make this presentation. I realized this was not in my original presentation, because all of the research I had looked at when I originally made this presentation up 15 to 20 years ago didn't mention the fact that William Herschel actually had a younger sister named Caroline who helped him, who was an assistant to him all the time that he was doing his astronomy in England, and she herself became a very accomplished astronomer herself, and not an amateur. She was so helpful to William when he became a professional that the royal court, King George himself, paid her a salary. So she was a real professional astronomer, and she added to the catalog, the NGC catalog, with many, probably thousands of deep sky objects that she discovered herself. So again, this just shows you that women are finally having their day. They're finally getting their recognition. Okay, now we come to the king, who I call the king of amateur astronomers. This was Percival Lowell. So any of you know anything about Percival Lowell? That name should ring familiar with some of you. Okay, Percival Lowell, he was a guy, again, he was an American mathematician. He got no formal training in astronomy, no advanced degree in astronomy. He had a BA from Harvard University, but it was in math. Okay, and, excuse me, was it math or was it business? So what he did in life, to make a living, he was a diplomat. He spent a lot of time in the Far East. He was an attaché for the United States government in Japan. He spent most of his time in Japan and in Korea, and in fact wrote a few books about Japanese and Korean culture. He was an author, businessman who trained himself, but in his free time, he trained himself in astronomy. Okay, traveled extensively in Far East, 1880, serving as, there it is, American Foreign Secretary and counselor in Korea and living in Japan. Wrote several books on Korean and Japanese culture and society. He was elected Fellow of the American Academy of Arts and Sciences in 1892. After returning to the US in 1893, he read a book on Mars, La Planète Mars, by Camille Flammarion, and became familiar with the drawings of Italian astronomer Giovanni Schiaparelli. And these drawings by Schiaparelli became infamous because they were the first ones, first very realistic drawings of Mars. They didn't have photography, astrophotography in those days. So the only images that we had of planets, guys would look into the telescope and they'd have their paper there and they'd just draw. Okay, here's Mars. And we have to take their word for it, But thankfully, a lot of these guys were pretty good. They were very good artists. And Schiaparelli was very good. But the problem was, in his very good, very realistic renditions of what he saw, he painted these, he would include these lines, which he called canali, which in Italian just means a line, okay? Is a channel or something. But the rest of the world, especially Americans and Brits, we mistranslated that into meaning, canals with water. They must be, if they are canals with water, then they are obviously the result of intelligent life. These are Martians irrigating their land, their arid land, with water from the poles, okay? So they're building these canals to bring water from the North and South poles into the arid central part of the planet. And that's how we start getting these ideas that, oh God, Mars is inhabited by these little green men, and because its conditions are so dry and getting worse on Mars, they want to invade the Earth. So we have invaders from Mars, thanks to the work by Giovanni Schiaparelli. And Percival Lowell bought it, hook, line, and sinker. From that moment on, he became obsessed with Mars, and he was convinced that Mars was inhabited by intelligent life, and he spent the rest of his life. He was, by the way, very wealthy. His family was very wealthy. So he had a lot of money to spend. So what he did when he retired from the US government service is he built his own observatory up on a mountain in Flagstaff, Arizona, and that's what we know today as Lowell Observatory, okay? And so he built a large refracting telescope. At the time, it was the largest, 24-inch Clark refractor telescope, and he spent hours just like this, seated at the eyepiece of that telescope, and he making his own sketches, and all of it trying to prove that there is indeed intelligent life on Mars. Okay, here are other pictures. I had the great good fortune of making a trip there myself, but this is like 20 years ago, because I was living in California at the time, so it wasn't too difficult to drive over to Flagstaff, Arizona. And this is the primary observatory. See, the amazing thing about his observatory is it's all made of wood. At that time, in the end of the 19th century, lumber was still cheap. You cannot imagine what it would cost these days to build something like this out of that much lumber. So obviously there are strict measures taken to make sure that this thing doesn't catch fire. Because if it ever did, if it was ever destroyed, it would be irreplaceable at today's cost. So anyway, you can see that instead with metal observatories, you have a nice rounded dome. Here you have what I call an upside down ice cream cup. So, this happens to be, bless his heart, his mausoleum. When Lowell died, he was cremated, and his ashes were interred in this little mausoleum. It's about this big. You come out, you look at it, and you would swear that if you just close your eyes, this thing's going to take off and float off to Mars and land on Mars, which is what he would have wanted, I'm sure. Okay, we've got to wrap up here. Unfortunately, he inspired all of this science fiction, the War of the Worlds, but unfortunately, it worked to his discredit, and he died, unfortunately, with a ruined career. Everybody laughed at him. Final guy, the prince of all amateur astronomers, Clyde Tombaugh. He started out, he was a Kansas farm boy, okay? So he was working on his family's farm, but he developed a real interest in astronomy. Again, his father, for his birthday, came one birthday, gave him this telescope from, I think it was a Sears in Kansas City or something. And he said, boy, this is a real piece of junk. So he said, all right, I'm going to, again, make my own telescope. He did. He used it, made his own sketches, sent the sketches to Lowell Observatory just to get their opinion on what they thought of his sketches, and they ended up offering him a job. They said, boy, your sketch is so good, you come work for us. And so then at that point, he started studying astronomy in earnest and became a professional astronomer while he was there. And while he was there, even when he was still a kid, just after they hired him off the farm, they put him to work because Percival Lowell had predicted with his mathematical calculations that, there's got to be a planet somewhere out there beyond Neptune. There has to be a ninth. Up until then, there was only 8 planets in the solar system. But Percival Lowell, in his calculations, said, there's got to be a 9th planet out there. So they put him to work pointing a 13-inch photographic telescope at this patch of the sky where Percival Lowell predicted that Pluto, that this planet X would be found. And he spent, I think it was 3 to 6 months in this freezing cold every night taking images of this patch of sky. And finally, one night he discovered these faint 2 dots that seemed to have moved in 24 hours, and that was indeed Pluto. So this is how Pluto was eventually discovered, and unfortunately, Pluto is no longer considered a planet. Okay, so that's it for our three great amateur astronomers.
Thank you so much. That was excellent. We do want to thank Denis Cheng for that great presentation. Loved going through the history, learning about some of the key players. Very great presentation. And so what I'll do, we won't go through the conditions overview. We're not going outside with the telescopes. What I will ask is if you have not signed our sign-up sheet, please do so. It is optional, but we do like to keep track of folks who come. UACNJ is something that I continue to promote at every one of our meetings. It's a great place to go if you haven't gone. It's away from the city lights, and they do free public programs every Saturday evening. So these are two of the ones that are coming up, this one this Saturday, and then another one the Saturday afterwards, and there's the QR code if you want to scan it. Yes, but our next meeting is not the third Thursday of the month. It will be on June 5th. So in 2 weeks, we'll meet again. Same place, same time, same channel. And it's going to be about pulsars. Here's a little blurb about it, but it's on the East Brunswick Public Library website, on the calendar, and there's a QR code for it as well. So not the third Thursday next month, we'll meet June 5th. So if you're interested, come by, we'll be here. Hopefully the skies are a little better that day. I won't go through these updates. What I will recommend is you sign up for our newsletter. We'll go ahead and put the slide deck on there. There's a blurb about us joining the NASA's Night Sky Network. We are listed on there now, so if someone were to go and search for a club at the NASA website, we will show up there now, which is awesome. And did you know we are a part of the UACNJ, the United Astronomy Clubs in New Jersey? We are an associate club. We are listed on their website. We'll have to give them the updated logo, but we are there. And there's actually a perk with us being a part of that organization. You can volunteer at UACNJ. There is a fee, but you get access to their facility, to their equipment, as long as you get certified. If you're into amateur astronomy, there's a huge benefit in doing so. So sign up for the newsletter. You'll get the slides, you'll get the links, or go directly to their website for more information. And then a quick reminder, you might want to take a picture of this. On August 21st, we're having our first quick fire presentations, 5 to 10 minutes. Anyone is welcome to give an astronomy-related topic presentation. So if you've been hoping to do something like what Denis did today, the barrier for entry is much lower. It's only 5 to 10 minutes. No pressure. We're a welcoming group. And there's no age requirement either. It just has to be astronomy related. So we open the floor and give you 5 to 10 minutes to do so. That link is to a form to sign up. Just give us your information, who you are, what you're looking to present, and we'll put you on a slot. And of course, follow us on Facebook and Instagram. We'll, continuously share updates. Some of the stuff that I shared today will be on there. Our upcoming meetings, things like that. So by all means, follow us on social media, check our website, sign up for the newsletter, all of the above.